It's time we learn about air pollution. So, air pollution, for the most part, is caused by the burning of fossil fuels. There are other things that can cause air pollution. We'll study those as well. But the main thing that causes it is the burning of fossil fuels. Now, fossil fuels include things like coal, gasoline, diesel, natural gas, and a few other things. And the thing about fossil fuels is they all contain carbon, and at least coal is almost entirely carbon, and most of the other ones are made of both carbon and hydrogen. So collectively, we often refer to these things as hydrocarbons. Now, let's just talk about how they formed. So coal, it was formed, I should say, from plant matter that primarily grew in ancient swamps before the age of dinosaurs during an era called the Carboniferous. And so at the time, much of the world was lowland areas. There weren't a lot of mountains at the time, and there was these swamps that formed. And when trees would grow, they would capture. They'd do photosynthesis. They'd capture all this energy from the sun to be stored in the cellulose of their tissues. They'd fall over, and all that energy was present in their tissues. Uh, but then the water that they fell into was very low in oxygen, high in acidity, and so there weren't a lot of bacteria that could then eat the plant, so they didn't decompose. And over time, they got converted into a substance called peat, which you can still see this happening today. But then what happens is over time, with more and more matter deposited on top of this, peat gets the water squeezed out of it. I like this diagram. It gets heated up, and it becomes what's known as brown coal. Brown coal is really not particularly, it's a very dirty kind of coal. Some people burn it. It's not good for the environment. Now, within additionally heat and pressure, it becomes better and better coal. So it becomes what's called bituminous, and eventually it becomes what's known as anthracite coal. Anthracite coal is the best coal. It's very black, very shiny. And it's mostly made out of carbon. But the point is, it's made from plant matter that grew in swamps and then didn't decompose. And it's been stored underground for like 600, 700 million years. So it's fossil fuel. Now, what do we use coal for? For the most part, coal is used for generating electricity. The vast, vast, vast majority of electricity on this planet is generated by burning coal. You take coal, you burn it. By burning it, you make steam. The steam that's produced turns a turbine, which spins a magnet, which makes electricity. Now, the problem is, in addition to containing carbon, which is going to make carbon dioxide when it burns, there's also a lot of other things in it, like lead and mercury and sulfur. And these cause a lot of the problems that we have in our environment today. Now, gasoline, another fossil fuel, forms in a fairly similar way. So instead of terrestrial plants growing in swamps, what we have is aquatic organisms. Now, that's showing like seahorses and octopuses, but really what it is more like plankton, zooplankton, phytoplankton, small fish, things like that, and algae. And when these things die, they sink from the photic zone down into the aphotic zone, where there's very little oxygen, and there's just not much ability for bacteria to digest them. So the energy that was in their body when they die just stays in them and gets buried in mud at the bottom of the ocean. Usually this happens kind of near the mouth of a river where it get buried in mud. And then what happens is over time, like with coal, heat and pressure will break down the proteins and carbohydrates in their bodies, the fats, and turn it into this complex solution of hydrocarbons that we call crude oil, which we then pump to the surface, refine, and use. So crude oil is a mixture of hundreds and hundreds of different hydrocarbon compounds. And these tend to be carbon chain compounds, whereas coal is almost entirely just carbon, 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 carbon. This is carbon linked to hydrogen. And it can take various forms. It can be a chain, as in this one here. This is actually a branched chain. This is a straight chain. It can make rings, these benzene rings. So there's this slew of different compounds together that make crude oil. And what oil refineries do is they separate these out, and they use different ones for different things. So some of them will become gasoline, some of them will become diesel, some of them will become fuel oil, and so on. But they're all basically the same thing. They're made out of oil. Now, collectively, we refer to these things as volatile organic compounds, or VOCs for short. Volatile means they evaporate. Organic means they're made out of carbon chains. And you can tell this because VOCs tend to be aromatic. We tend to notice them in our noses. So think about, you've smelled gasoline, you've smelled diesel, you've smelled, say, like fingernail polish remover, and paint stripper. Those things are all VOCs, volatile organic compounds. And they basically are carbon chains that start off, for the most part, they come from petroleum, which is oil. So gasoline and diesel are two products we get out of crude oil. They're sort of medium chain, length chains of carbons, and we use these things for powering automobiles, trucks, jets, and things like that. So most transportation technology is based on the burning of these sort of medium chain oil products called gasoline and diesel. Natural gas is the smaller chains, like one carbon, two carbon, three carbons, and these are the things that we pump into people's houses and use for gas stoves. We can compress them, put them in some of our modern cars, have compressed natural gas or liquefied natural gas (LPG), and we also use them for generating electricity. And they're a lot cleaner to get electricity from burning gas than it is from burning coal. But still, most electricity is not produced that way. Now, listen, under ideal conditions, here's what's going to happen with all these fossil fuels. They're always going to produce the exact same two products, carbon dioxide and water, just like what you breathe out, like respiration, carbon dioxide and water. We take carbon chain molecules, sugars, we react them with oxygen, and out of our mouths, our exhaust is carbon dioxide and water. Well, that's what happens with a coal-fired power plant. You put in coal, which is just carbon, react with oxygen. Oh, look at this. That's embarrassing. There's no H2O that comes out there. That's it. Avoid. Do not show Mr. Vote this, okay? That's a mistake. Okay, so you just get CO2. With gasoline, you have octane, C8H18 plus O2 is going to make CO2 plus H2O. Natural gas, methane, is CH4 plus O2, CO2 plus H2O. That is what happens under ideal situations. It's so embarrassing that I did that. Anyway, I don't want to redo it. I'm on a roll. What happens is, though, if oxygen is not present in the perfect ratio, then you can't make that happen. What happens instead is you end up producing an air pollutant called carbon monoxide. So what happens is, there it is again. In addition to getting CO2, you'll also get CO, carbon monoxide, and that's true for both coal and natural gas and gasoline and so on. So CO, carbon monoxide, is a pollutant that what you need to know is a result of basically an improper mixture of fuel and oxygen, which is really easy to do. It's almost impossible to get the perfect mixture. Now, here's what's so bad about carbon monoxide. It is what's known as an asphyxiant. So it's not that it's poisonous per se, but what it does is normally the hemoglobin in our blood, the purpose it serves is it is able to attach oxygen and carbon dioxide. So it can pick up carbon dioxide from our cells and carry it to our lungs, and pick up oxygen from our lungs and carry it to our cells, and it can let go of them when it needs to. But what happens is, when carbon monoxide gets into there, it joins to the hemoglobin, and then the hemoglobin can't let go of it. And since the hemoglobin is holding onto the CO and can't let go of it, it is unable to pick up the oxygen and carbon dioxide that we needed to. So over time, our blood basically becomes useless. We essentially slowly suffocate. And this causes basically neurologic problems, seizures, and death. Now, another thing we get from fossil fuels, another pollutant, is nitrogen oxides. And nitrogen oxides happen because internal combustion has very high temperatures. And the temperatures at which we're burning fossil fuels, it turns out, is hot enough to get nitrogen to react with oxygen too. Remember, the atmosphere is about about almost 80% nitrogen, about 20% oxygen. So most of that nitrogen doesn't do anything. But in high temperature combustion, what happens is we take gasoline. We want oxygen, but we don't bring in just oxygen. We bring in air. So we bring in air because we want the oxygen. We react the oxygen with the gasoline. But in the process of doing that, that high temperature causes some of this to react with some of this. So what comes out the exhaust pipe of the car? CO2 plus H2O. You know what? We're probably going to get the mixture wrong, so probably a little bit of CO as well. But nitrogen oxide, nitrogen dioxide, which we did not mean to make. Now, these are two of the main components. Now, you can make other kinds. There's a number of these molecules. So collectively, we just refer to them as NOx, meaning like, well, the different various nitrogen oxides. Now, nitrogen oxides are really bad. Okay, they are a major component of smog. When the air gets that brownish haze, those are the nitrogen compounds. And so they also are responsible for aiding in the formation of ground level ozone, which is a really, really damaging compound. But even on its own, NOx, nitrogen oxides, they cause eye irritation and they cause some lung complications, especially people with compromised pulmonary systems. Now, another pollutant, I mean, right? There's just so many different, don't worry, there's not too many. Another one that we get is sulfur dioxide. So now sulfur is commonly found in coals, especially low grade coals like brown coals and bituminous coals, less so in anthracite coal. So we sometimes call this dirty coal. It's also present in, okay, Mr. Paul wants to go home, but I'm going to keep doing this. I give him a ride home, so he has to wait for me. What we find is that it's also present in diesel. So diesel fuels often have a very high amount of sulfur, and so what happens is when they react with oxygen, when coal and diesel react with oxygen, they accidentally produce sulfur dioxide as well. Now, sulfur dioxide is the main source of acid rain, which is something we'll also be talking about. Uh, and just on its own right, though, exposure to SO2, it causes irritation of the eyes and mucous membranes, and also it can result in reduced lung function. Ozone is a great thing in the stratosphere. It protects us from ultraviolet light. Without it, we'd all have skin cancer. But it's not great here at ground level. And what happens is normally oxygen we breathe is O2, but sometimes it picks up this extra O that's not held on very tightly, which and then breaks off and then reacts very aggressively with our tissues. So ozone is really, really bad for us, especially for people who have compromised pulmonary systems and lung problems. So if people have asthma, bronchitis, emphysema, basically it often kills them. I mean, a lot of people die every year as a result of air pollution. I think something like 4 million people a year in the world die. 18,000 Koreans die every year from air pollution. So it's a pretty major problem, and a lot of what kills them is ozone. Now, ozone is an example of what we call a secondary pollutant rather than a primary pollutant. So a primary pollutant is one that's emitted directly into the air. A secondary pollutant is one that reacts with a primary pollutant and then gets made in the air after the fact. So we're not putting ozone, it's not coming out of my car, it's not coming out of the smokestack of a power generating plant. But what happens instead is it gets into the atmosphere because NOx and VOCs in the air react with sunlight, and they end up forming it as a chemical reaction. So the O3 happens as a consequence of primary pollutants reacting with sunlight and heat to form these secondary pollutants, and we call this photochemical smog. Now, how do these volatile organic compounds get where they come from? Well, VOCs are basically they're aromatic hydrocarbons for the most part, right? So you've ever smelled gasoline that's being pumped? Well, that means it's going into the air. Cars don't always burn all the fuel that goes into them. So one of the things that comes out of a car exhaust is also unburnt fuel. Plants make natural VOCs. A lot of industrial practices, a lot of construction processes. Anytime you smell something, that's usually a VOC. So VOCs, they include things like gasoline, benzene, formaldehyde, which is used in a lot of construction products, the solvents, things that we use for dissolving things, paints, and so on, fuels. All these things are volatile organic compounds, and they are a fairly common air pollutant. Now, particulate matter is one of particular concern because particulate matter comes in two sizes. We talk about PM10, that means 10 microns, and then PM2.5, which is just 2.5 microns. It's very tiny. And so these particles are so small, they can be little dry particles, they can be little wet droplets, but they're so small they can be inhaled very deeply into our lungs. They can get through our lungs, into our bloodstream, into our organs, so they can be quite damaging to human health. And it comes from a really wide variety of sources. It can just come naturally from the soil or because humans have been interacting with soil. If you go to the ocean, you see this haze, that's sea salt. It's totally normal, but it's not necessarily healthy for you. You look at the trees there, they often seem kind of stunted. Soot, which is basically carbon particles coming out of factories, from forest fires, vehicles, construction sites put a lot of this in the air, heavy metals from power plants, smelting, that means where we're making the metals, and from construction sites, demolition. All this can put this, it's just a whole bunch of different sources, unfortunately. It's not so easy to contain it, but it's a particularly bad one. It causes a lot of health problems. Now, the air quality index is basically a scale for measuring how unhealthy air is. I'm sure you've heard of it. We use it all the time here at KIS. And basically, it's an artificial scale that goes from 0 to 500. And it's basically just a way of taking the level of particular particulates, weighting them for their health effects, and then aggregating them together and saying, okay, based on the different concentrations, we basically have a weighted value for all those different types of the VOCs, the particulates, the O3, the NOx, the SO2, put it all together and say, okay, based on this, here's how dangerous it is for you to be breathing the air. So basically, AQI is a composite of ground level ozone, carbon monoxide, sulfur dioxide, nitrogen dioxide, and particulate matter. Okay, so that's pollutions. I better take Mr. Paul home. He'll get mad at me. Oh, I'm still going. Sorry.